It's Friday, the 20th of November. My name's Juan Brown. You're watching the Blanco Lirio channel. And on 15 November, a Southern Air Transport Boeing 777-200 had a low-speed event while departing New York's JFK airport en route to Seoul, South Korea on a cargo flight. Our friend Victor at VASAviation captured this event on ATC, so it's time for an update.
Who was that?
Southern Air 947.
Southern Air 947, you ready to contact? Turn 17050, call maintain 11000.
0505, stall.
But first, let's start by answering one of the great questions posted on Victor's YouTube page. Do the pilots get in trouble for an incident like this? In order for an accident or an incident to happen, it has to follow a chain of events to the incident. And that chain of events has to pass through many barriers in the safe operation in order to result in an accident or incident. By the time the chain of events slips through all the different barriers and comes down to the aircraft and the aircrew, it is up to the aircrew's training in order to save the aircraft. And in order for the aircrew to get the proper training to save the airplane, this is primarily done through AQP, or the Advanced Qualification Program style of training, not just the minimum FAA requirements to meet a ATP pilot rating, but to take real-world scenarios and put the pilots through these real-world scenarios and teach them how to recover from them. In order to find out which real-world scenarios we need to train to, we use a series of voluntary reporting systems. I just got through my Boeing 777 requalification program, and at the end of the requalification program we did AQP training, and that training included, among other things, stalls in the Boeing 777, both high altitude stalls and low altitude stalls. So how do we collect this data, and how do we determine which scenarios should we install in the training programs? There are two different basic programs that capture this data. One is FOQA, the Flight Operational Quality Assurance Program, and two, the ASAP program, Aviation Safety Action Program. All modern airliners today are equipped with data recorders. This data is periodically downloaded and reviewed for exceedances. Anytime an exceedance is observed in the data, somebody called a FOQA gatekeeper will flag that data, will notify the aircrew, and through anonymous reporting, they'll capture that data and get to the bottom of the story is what happened to this aircraft that resulted in an exceedance. This data is then fed into a database, and if there's a trend, an increasing trend in this data, then it will be addressed in training. On the pilot's end, you have the ASAP program, which is referred to in the vernacular as sort of a get out of jail free program, where a pilot or aircrew can voluntarily report what they believe to be a possible violation of FARs or an exceedance with the aircraft, and get that information to the FAA within 24 hours. Now you put these two pieces of data together, the FOQA program and the ASAP program, and we are able to voluntarily collect important aviation safety data and act on it. So back to your question, will the pilots get in trouble for this? Well, not if they follow the procedures, and if they file an ASAP report within 24 hours of the incident, and if the FOQA gatekeepers, assuming that Southern Air Transport in this particular case has a FOQA program, if the flight crew responds to the FOQA gatekeepers and files an ASAP report, they will more than likely not get in any trouble for this particular event. And the data that they report may very well report other problems with the barriers prior to the pilots having to take action to prevent this stall from becoming a major disaster. So let's go inside and take a closer look at what happened to this crew on the ATC tape and talk in general on some of the considerations for a Boeing heavyweight departure. Okay, let's start with our friend Victor over at VASAviation and Real Live ATC.
Southern Air 947, fly runway heading. And contact park now 125.7. Good day. Runway heading over departure, Southern Air 947.
They're departing runway 22 right at New York's JFK Airport.
Kennedy, Southern Air 947, 2000, climbing 5000, runway heading.
Remember, this number here is the altitude, 1,800 feet. This number here is the airspeed, 210 knots.
Charlie, you got the frequency again? 125.7. 25.7.
If it sounds like they are tired, the crew of the Southern Air aircraft, they probably are. They're freight dogs. They're freight pilots. Even though it's 2:30 in the afternoon local time, New York, they've already been delayed, according to FlightAware, an hour and a half, and they're getting ready for a very long flight. So getting those frequencies, normally you have those frequencies already set up in standby. You got the tower frequency in the active side of the radio, and you got the departure frequency already set up in the standby side of the radio, and you just hit a button and flip the frequencies over. But sometimes those frequencies do get mixed up, and you got to go back to the previous frequency to verify the next frequency.
Okay, departure, Southern Air 947, 4000, climbing 5000.
Beep, 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 beep. You hear that? That's the yellow caution warning indicator on the Boeing 777. They're at 3,600 feet, and according to this, only 200 knots. It's hard to tell how accurate this airspeed data is on this recording here, but it can show you the trends.
Who was that?
Southern Air 947.
Southern Air 947, you're ready to contact. Turn left heading 050, climb maintain 1000.
4,000 feet, 210 knots.
0505, stall.
Okay, you heard the FO holler stall to the pilot flying. Again, let's review the divisions of duties here. You have a pilot flying the aircraft and a pilot monitoring the aircraft. And the pilot monitoring the aircraft is who we are hearing on the radios. So in this clip, we heard the beep, 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 beep of the amber caution light in the Boeing 777. And then we heard the doo-dah, doo-dah, doo-dah. That's the red warning aural signal in the Boeing 777. And we'll talk more about those in a minute.
Southern Air 947, standby.
Yeah, like Victor says here, he's now at 3,900 feet and 220 knots. So he's coming down slightly in altitude.
Approach good day, Group Airlines 526 9000 Yankee.
Ready, standby. Triple 224, turn left 240, join the localizer, your third ILS 22 left.
240, join the localizer, clear for the ILS 22 left, just move 224.
3,800 feet, 250 knots.
Departure, exact jet 564, leaving 1.7 for 3,000 on the 220 heading.
Standby. 747, can you climb?
947, standby.
3,700 feet, 260 knots. So he's giving up a little bit of altitude, not much, a couple hundred feet, for airspeed, and he's continuing out straight ahead. He's not beginning that left-hand turn, and he needs to continue straight ahead. He's threading the needle.
JetBlue 224, tower 19-1.
Tower 19-1, JetBlue 224.
Approach Group Airlines 526 9000, approaching Cameron Yankee.
526, turn right 040, sectors ILS 22 left.
040, vectors 3 ILS 22 left, Group Airlines 526.
4,100 feet, 270 knots.
45226, turn left and 310.
Left, 310, 226.
Exec jet 564, Congo 12,000.
12,000, exact jet 564.
Virgin 3 November Heavy, descend maintain 5,000.
And maintain 5000, Virgin 3 November Heavy.
Still continuing straight ahead, 4,800 feet, 270 knots.
Southern Air 47, maintain getting you altitude.
Yes, say again, Southern Air, you're good now?
Yes, we are, maintain getting altitude.
Yes, Southern Air 947, turn left to 090.
Left heading 090, Southern Air 947.
So they made it to their 5,000 foot altitude. They've got their airspeed under control, and they're ready to continue on their departure. There's one more thing I want to show you. Fast forward ahead here.
45226, thanks for the help. Turn back right, direct Kennedy, resume on nav.
Back to JFK 226.
Southern Air 947 Heavy, you want to continue a climb now?
Southern Air 47, we can continue climb.
Southern Air 947 Heavy, turn left heading 050, climb maintain 1000.
Left heading 050, climb maintain 1000. Southern Air 947 requesting high-speed climb.
Speed is your discretion, sir.
Thanks, sir.
That's something that should have been done ages ago in this situation. Let's talk more about that. FAA regulations here in the States requires that everybody remain at or below 250 knots indicated airspeed below 10,000 feet. And this is for controlling purposes to keep everybody together in tight airspace. When operating heavy aircraft on these long international flights, it's very common to request relief from this regulation. And you need to request relief from this regulation long before you even reach 250 knots. So in other words, you need to begin coordinating a request for a high-speed climb either with the tower or as soon as you switch from tower to the departure control frequency. You want to have permission for a high-speed climb long before you reach 250 knots. Why do you need a high-speed climb? Because you're so darn heavy, your min maneuvering speed is approaching 250 knots. We'll show you more on that on the airspeed indicator here. Now here's a typical airspeed indicator for a Boeing 777-300 doing a high-speed climb right after flap retraction. Over here on the left, since I don't have a pointer and I can't point on this image, you're going to have to bear with me here being the center of attention. Over here on the left is the airspeed indicator, and this is indicating 258 knots. Over here on the right is the altimeter going through 5,820 feet, climbing at a rate of 2,000 feet per minute. So in this picture, it's indicating a high-speed climb above 250 knots, below 10,000 feet. The green up indication is your min maneuvering speed, indicating that this is a very heavy aircraft. And that min maneuvering speed is 251 knots. That's your first clue when you look at the paperwork long before you take off that you're going to want to request a high-speed climb. And you fly these same old routes with these same weights over and over again, you pretty well know when you're going to need a high-speed climb long before you even head out to the aircraft. Below the green up indication is the yellow arc, the yellow hook. That's your 1.3 G, about 40-degree bank, min maneuvering speed. It's telling you you're fixing to stall. You're below your min maneuvering speed, and you're cutting into your 1.3 G stall margin, because just below the amber hook is the red zipper. That is where you will actually get the stick shaker. And though you're getting the stick shaker, the aircraft is not quite completely stalled yet, but you are pretty much right there on the stall when you hit the stick shaker. So if you allow this airspeed to decay enough to enter the yellow hook, you'll get that beep, 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 and a airspeed low ICAS warning. I suspect that's what we're hearing in this ATC audio tape. Note also the yellow PLIs in this example, pitch limit indicators, which correspond with the stick shaker and the top of the red zipper on the airspeed indicator. If you pull the nose up those last couple of degrees, that's where you'll get the stick shaker. And on the Boeing 777, that'll take a substantial amount of aft stick pressure. So the PLIs are a visual representation of where your stalling critical angle of attack is for this given configuration. Now let's talk about some of the built-in protections designed into the Boeing 777 aircraft that helped get this crew out of this rather tight spot. And this is a fundamental design difference between Boeing aircraft and Airbus aircraft. In the Boeing aircraft, if your airspeed decays down into the yellow or the amber hook there, you can no longer trim nose up. You will have a tremendous amount of, if you continue to pull back on the yoke, those forces will continue to increase. Also, too, the autothrottles will wake up and go to max continuous power and command either the higher of min-maneuvering speed or the airspeed set in the mode control panel. If you allow the airspeed to continue to decay further into the red zipper, you're going to get a stick shaker and a master warning caution and that beedo, beedo, beedo. In the Boeing 777 series of aircraft, you won't get a ARL stall warning. Instead, in this case, it was built in to the pilot monitoring. Now, add to this the fact that on the 200 series of 777, you have a flaps 1 speed limit of 270 knots. So if the flaps were still at flaps 1, you'd have another red zipper up here at 270 knots and increasing. So you have just about a 30-knot window there to work with, sometimes even less, when you're maneuvering from flaps 1 to flaps up. And this illustrates a fundamental design engineering philosophical difference between Airbus and Boeing aircraft. Boeing aircraft, you always have complete control of the aircraft, even though it's a fly-by-wire flight control computer system. You can physically fly the airplane into a stall, but you really got to horse it into it. You got to overcome some pretty tremendous yoke forces in order to do that. The Airbus fly-by-wire system, which is just a joystick on springs with no feedback at all, no feedback at all into the control stick, you can honk that control stick all the way back. The airspeed will decay to min-maneuvering speed, and it will stay there. It basically takes over control of the aircraft and will not allow you to enter a stall. In both of these cases, as long as the flight controls are in the normal law condition, everything's working normally. So we still need a lot more information, the CVR data, to find out exactly what happened here. Was the correct information input to the FMC in the first place? Was the weight and balance done correctly? Were the weights done correctly? If you've got the wrong weight in the aircraft, you're going to get the wrong flaps up schedule. Were the flaps retracted at the correct air speeds? Was there a premature flap retraction below a recommended airspeed for a particular flap setting? Lots of different things we still need to find out about this, and hopefully through this reporting system and the FOQA data, we can figure this out. So I hope this gave you a little better understanding of what happened to the Southern Air Transport heavyweight departure out of New York on 15 November. Thanks again so much for your support of this channel, and thanks so much for the folks on Patreon that make this content possible. See you here.